2 is a fixed number, the calculation is based on the working distance, size, specimen, the angle. It's a triangle formula. It's a mess, so we don't have to talk about that. 2 is a fixed number. So 2 right here. What is the again? Numerical aperture. What is that? I will show you in the lab later on. If you see a lens 100x, you will always see a very important number below it said 1.25 OU. What is this number? That is called numerical aperture. Acronym NA equals 1.25. And I always say numerical aperture is like size of the microscopy engine. G-I-N-E. Microscope of the engine. Like the size of the car engine. So let's do a calculation. 625 nanometer divided by 2 multiplied by 2.5. 625 nanometer divided by 2.5 equals 260 nanometer. That equals 0.26 micrometer. So then we have another question for you. If I have a bacteria, Staphylococcus aureus, what do you think is the size of a bacteria? What do you think? The size? Obviously it's small. Then how small it is? The average size is about 0.5 micrometer. This size is larger than the resolution power. The resolution power equals 0.26 micrometer, which is less than 0. Therefore, we could use bright field microscope to do the observation. Because the resolution power is less than the average size of the Staphylococcus aureus. Now I have another question for you. What is the average size of a virus? Let's say a HIV virus. What's the average size? It is 10 nanometer, 0.01 micrometer. Can we use bright field microscope to do the observation of a virus? Obviously no. Otherwise, why we need these? Because the resolution power equals 0.26 is larger than 0.01. Therefore, this doesn't work. So this is where the formula tells you the resolution power, what it is, how we do the calculation. And from here you could see, we want this resolution power. The value, the smaller the better. Okay, so resolution power value, the smaller the better. Now, we cannot change 2. We basically cannot change numerical aperture 1.25. What we could change is this lambda. The wavelength could be changed. Is that right? We couldn't make it smaller. Therefore, it comes out with shorter wavelengths will cause larger resolution power value cause a very strong resolution power capability. That means you using a bright field microscope has a shorter wavelength. It has a very strong resolution power, and you could see the microorganism much more clearly. What we want to see, we want to see the morphology, we want to see the arrangement. Because we could give a brief idea what it looks like, and it could do a preliminary diagnosis. So we will talk about that later on. If we do a staining technology, we get a sputum sample from a patient, he's keep coughing, had a fever. We find it is a chain shape. It is a chain shape, it is a coccell. Then possibly streptococcus. Then what you need to do? We need to using antibiotics immediately. Otherwise, this person gonna have trouble. And then you're gonna ask me how we isolated. Lots of the bacteria, we do the isolation, we do the confirmation. It took a couple of days, not that quick. E. coli, we could took 1 day to do. Tuberculosis took 2 weeks. So you can say, okay, go home. We're gonna do the identification. When we fixed, we find out what it is, go back, I'll give you antibiotics. That's too late. That's why a very nice, a strong resolution power with shorter wavelengths of the light field microscope is important, although it is relatively expensive, because that could tell you the clearly morphology arrangement of a bacteria. Okay? So we have still a little bit of time. We want to finish the next one. Slides here which tells you lens, the bending, light, reflection, oil, everything, and basically covered. But this oil immersion to remove the air gap, and we want to talk about the dark field microscope. And we'll end of today. So we're spending a chunk of time here talk about the bright field microscope, and we want to talk about dark field microscope. What it is, what we're talking about. It's another very smart tools. Okay, dark field microscope. Microscope, you should say. So what is bright field microscope, first of all? Bright field microscopy. I didn't mention this. The specimen is usually dark. Background is bright. So you can see it. What is dark field microscope? Opposite. The background is dark, and the specimen is relatively light, or we say bright. Now, how they do it? How they achieved it? Obviously, you need to do something for the structure of the microscope. So, how they do it? Okay, I had a microscopy like this. Okay, I have this stage. I have the lens. I have the light resources right here. And I have a condenser is here. What happened? What's the structure special? Underneath condenser, we put a very solid block. Once we put a very solid block, the light going through the lens, it is perpendicular, 90 degrees. So, when you put your eye in the ocular lens, you will see the background is dark and the specimen is bright. Now, you're going to ask me why this is important. in the clinical area, this is very important to diagnose a special bacteria called spiral sheet. Spiral sheet is a very special bacteria. Asexual filament have endoflagella, and you cannot do the staining because it's too soft. The tissue is too soft, you can understand about it. So you have to use in dark field microscope. What are the examples of spiral sheet? This is the first one. Treponema pallidum. Why this is important? This will cause #1 sexually transmitted disease in the world, syphilis. Is Treponema pallidum. The second one, Borrelia burgdorferi, is caused Lyme disease. That's the two major things. Okay, that's why it is important. Because clinically, with these two diseases, we'll mention about later, you need to fast to do the identification. The light field microscope not working. So, we have to use dark field microscope because they belong into the group of spiral sheet. Another one, Leptospira interrogans. This guy is very special. Looks like this hook shape. This is coming from rodents. If you have a flooding area, you have an animal goes everywhere, dogs, rabies, and then skunks, and they have a fecal sample, stool sample spread everywhere. You could get contamination. And you have like yellow eyes. What is called? Jaundice. Because it's called cause liver disease. It's very penetrating. Okay, with these type of the bacteria, we need to use dark field microscope. Okay, so this is all I have today. Usually I off class a little bit earlier. Start from next week Tuesday, I will bring a sheet and to check your attendance. I may call you the first time just to get to know you. What's your name? I usually know everybody after a couple of classes. I don't want to be teaching you a whole semester. I don't know any of you. Okay, so that's what we do.